In this lesson, we'll look at some more string manipulating functions, starting with string comparisons. There are several functions that allow you to compare two strings. strcmp, or string compare, that's the basic one. What it will do is compare two strings and return logical 1 for true if they are the same, or 0 for false if they're not, or if they're not the same length to begin with. For strings, we use this instead of the equality operator. MATLAB has several variations on the string compare function. strncmp compares only the first n characters, where n is an integer. strcmpi is short for string compare ignore case, so it ignores whether the letters of the alphabet in the strings are upper or lower case. And putting those together, we also have strncmpi, which will compare the first n characters of the two strings, ignoring the case. MATLAB also has find and replace functions. strfind, or string find, finds all occurrences of a substring within an original string. So you pass to it two strings. The first is the original string and the second is the substring. And it will find all occurrences of the substring within the original string, returning a vector of the indices of the beginning of the strings. Or if the substring isn't found anywhere in the original string, it will return an empty vector. The string replace function, strrep, you pass to that three arguments: an original string, an old substring, and a new substring. And what it'll do is it'll look within the original string for all occurrences of the old substring, and wherever it finds it, it'll replace with the new substring. And notice that the old and the new substrings don't have to have the same length. So you could, for example, go through the original string, look for all occurrences of x, and replace each occurrence of x with an xyz. The string token function, strtok, basically takes one string and breaks it into two separate substrings. That's all it does. It just takes one string, breaks it into two strings. All of the characters are there in either of the two strings that it returns. What it does is it looks for a delimiter, and by default the delimiter is a blank space, and it returns what's called a token, which is the beginning of the string up to the delimiter, and then also the rest of the string, including the delimiter. The default delimiter is the blank space, but if you want to have the delimiter be something else, you can pass a second argument to the string token function, which is the delimiter. So again, no characters are lost. All of the characters from the original string are returned in the two output strings. Since the function does return two things, the call to the string token function should be in an assignment statement that has two variables on the left, in which you're going to store the two strings that the string token function returns. Here's an example of using the string token function. I stored in a variable myString the string Isle of Skye, and passed that to the string token function. Again, since it returns two strings, I have two variables on the left of the assignment statement, first and rest. First is going to store everything up to the delimiter, which is the default of the blank space. So first is going to store the four characters ISLE. The second variable, rest, is going to store the rest of the string, including the blank space delimiter. So it's going to store space OF space SKYE, or 8 characters altogether, as the length function shows. If I wanted the delimiter to be something other than the blank space, then I pass a second argument to the string token function. So for example, if I want the delimiter to be y, then in f, we're going to store space OF space SK, and in R, the value of YE. So notice that I'm using the string token function, in this case, on the rest variable rather than the original string. The eval function is very useful. What it does is it evaluates a string as a function call or a statement or an expression, where usually you don't know what you're going to have in the string ahead of time. So it's something that the user enters, or it's something in a customized string. For example, I've created a variable x, which has the vector 1, 2, 3, 4, 5. Then I prompted the user for a function name, and the user is going to type in the name of a function, and I'm going to store that in a variable called fn. And then I'm calling the eval function, And what I'm doing is concatenating two strings together. So first of all, the value of the variable fn. So for example, if I type COS, that's going to be the value of my string variable. And I'm concatenating that with the string that contains parentheses x. So in other words, what I'm doing is I'm creating a string that has my string COS and concatenating that with parentheses x. So I've created a string that has cosine of x, and then I pass that to the eval function, and it evaluates it as simply an expression, cosine of x. So it's going to give me the cosine of every element in my vector x. There are a number of is functions that work with strings. The isLetter function will return true if the input argument is a letter of the alphabet. IsSpace will return true if the input argument is a white space character, and of course false if not. IsChar, what you do is you pass to it an argument, and it will tell you true if the argument is a string, or in other words, a character vector, or false if not. There are also some functions that allow you to convert from strings to numbers and vice versa. The int2string function will convert an integer to a string that stores the integer. Num2string will convert a real number to a string that stores the real number. And string2num is going to convert a string that has a number in it to an actual number. Or if that has several numbers separated by spaces, it will create a number vector. Notice that this is quite different from converting to and from the ASCII equivalents.